is called set notation. It's the last lesson that we will cover in probability. And U stands for the universal set. All of these problems are going to directly relate to what we see up above. So for this particular group of questions, we're going to refer to the universal set as the whole numbers from 1 to 9. Each problem, like if you turn to this page, if this will be your homework, here the universal set is all integers from 0 to 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, and all of these problems go directly with this universal set, okay? What I'm trying to get at is that we are not always going to assume that every universal set is just 1 through 9. Within this universal set, we have 3 distinct sets that they are going to classify. Set A consists of these numbers, set B, and set C. Okay, so just like we have different ways to represent the same thing, when we talk about something being a complement, there are 3 ways to represent a complement. This is one way, an accent symbol, or a line over the top. They all represent what is called a complement. A complement means, and first I'm going to show it by showing all my work, it means if you look at the universal set, in this case it's 1 through 9, and then you extract anything that is in set A. So set A says 2, 3, 5, 7. So take out 2, take out 3, take out 5, and take out 7. So if somebody said to you a complement, and they wrote it in any one of these 3 ways, your answer would be the set 1, 4, 6, 8, 9. Okay? Put your finger underneath B. If we said B complement, it means everything in the universal set except 2, 4, 6, 8. So what is B complement? It is 1, 3, 5, 7, 9. C complement is everything in the universal set except 4 and 8. So it is 1, 2, 3, 5, 6, 7, and 9. So complement can be written in any one of these ways. So look here. Is this a complement? It's a complement of set A. Is this the complement? It's a complement of set B. Okay, then there's 2 symbols that are commonly used in set notation. One looks like this. We call this the intersection. And the word and is used to describe it. It means what is in this set and the next set. So is what do they have in common? The other symbol you need to be familiar with is the union symbol. It means what's in set, for instance, set A or set B. So when you're working with the union symbol, you're going to push the 2 sets together and never repeat numbers. Okay, so we're going to start by showing our work for all of these. But when you get to the front side, if you don't want to show your work, it's going to be up to you and your partner how you want to complete this. Remember, you do have to have accuracy for the front side. It needs to be 100% correct. If you make a mistake, you'll just go back, figure out your mistake, and make a correction. Here we go. What is the complement of A? So let's start with the set. So I want to know what's in the universal set when I exclude 2, 3, 5, and 7. We already did that. It is 1, 4, 6, 8, and 9. And now I put the word or here because I'm just introducing the set notation symbols. Remember, or is the same as the union symbol. And now I want B complement. So what's in the universal set if I exclude 2, 4, 6, and 8? It would be 1, 3, 5, 7, and 9. The union, or, means let's push all these numbers together and never repeat. So do we have a 1? Yes. Remember, we don't double it up. Is there a 2? No. Is there a 3? Yep. And a 4. There's a 5 and a 6, a 7, and 8, and 9. Remember, we never repeat. Okay? The second one says, let's start again with A complement. Well, we already know that's 1, 4, 6, 8, and 9 from the previous problem. And now we have the word and. And means intersection. And the complement of set C means everything in the universal set when I take out 4 and 8. 1, 2, 3, 5, 6, 7, and 9. So now, with intersection, they have to be in both sets for us to put them in the final set or the final answer. Do they both contain a 1? Yes. They don't have 2s or 3s or 4s or 5s. They both have 6s, and they both contain 9s. So 1, 6, and 9. Bless you. A intersect B. So what's in A that's also in B? I don't think I have to show work here. So do me a favor right now. I want you to take 2 fingers, point one to set A and one to set B. Intersection means what's in A that's also in B. What do they have in common for numbers? They both have a 2. They do not both have 3s, 4s, 5s, 6, 7, or 8. The only number in common is 2. A union B means take A and B, write every number down that you see in either set but will never repeat. So I see a 2, 3, 4, 5, 6, 7, and 8. A intersect C. Okay, let's point to A and point to C. What do they have in common? Okay, come off to the side here. When they have nothing in common, you leave it blank in the inside, and this is known as the empty set. When it has nothing inside, it means there's no solution. So I'm going to put nothing. I'm not going to put a 0. I'm not going to put NA. Just leave it blank. This is a 2-step problem. First, I'm going to do A union B. And I'm going to cheat, and you're welcome to do the same. Do you see how we've already done A union B? Does everybody see this? Okay, so I'm going to refer up to this. And it says, take the complement of this. So what does that mean? It means what's in the union set when you extract the numbers 2, 3, 4, 5, 6, 7, and 8. So what numbers are left in the union when you take out this set? 1 and 9. We have not done A union C, so I'm going to do that right now. That means I'm going to push A and C together and never repeat. So when I push A and C together, I have 2, 3, 4, 5, 7, 8. 2, 3, 4, 5, 7, 8. Okay, that's the first step, but then it says take the complement of that. So, I'm going to change markers so it's easier for you to see. What is in the universal set for this problem, which is whole numbers 1 through 9, after I exclude these numbers? It would be the numbers 1, I have take out 2, 3, 4, 5, 6, take out 7, 8, and 9. This is A union B complement. That's what I have left over. And I want to intersect that with the set B. So I look up above and I write down what B is. Remember, intersection means what do they have in common? They both have a 6, and that's it. Okay, have I done A intersection B? I sure have, and the answer is 2. So I get to write down 2 here. And now I want to union that with C. C is 4 and 8. Remember, union means I'm going to push together the two sets and never repeat a number. One through 5 right now, and you're understanding? It's okay to be 1 or 2? Okay, these are even easier. What does this mean? It says if the percentage of getting A is 31%, it's written as a decimal. If the percentage of A is 31%, then what is the complement of A? That means just the opposite. So if you have a 31% chance of getting A, then what's the chance of not getting A? Well, it's out of 100%, so if I take 100% and subtract 31%, you end up with 69%, but write it as a decimal. If the probability of getting A is 42%, then what's the probability of not getting A? A complement. 58% written as a decimal. If the probability of A is 11%, excuse me, what is the probability of the complement of A? 89. This is often a confusing one for students, the last one. If the probability of A is, now how do you put that into a percentage?
100%.
If the probability of A is 100%, then what is the complement? 0.
I was right.